Good morning, everyone. I hope you guys had a great weekend and enjoyed some of the weather, especially yesterday. It was really nice out. Today we're going to start 7.3, which is hypothesis testing for the mean when we don't know the population standard deviation. So in most cases in real life, you're not going to know the population standard deviation. So we need to be able to go through the hypothesis testing process without knowing that. And if you remember, we did that back in chapter 6 when we learned how to use t-tests. Okay, so it's going to be very similar. We're going to work with t-distributions. Today we're just going to keep it very simple. We're going to find the critical values. So we've got our guidelines here. First, we specify the level of significance, which will be given to us. We'll identify the degrees of freedom, which if you remember from chapter 6 is the sample size minus 1. We're going to find the critical values using the table in Appendix B, which I have attached to the notes for you guys, with the row of n minus 1 degrees of freedom. And then we've got some rules here. When the hypothesis test is left-tailed, you use the one-tail column with a negative sign. So like whatever numbers in the chart, you just put a negative in front of it. If it's right-tailed, you just use whatever numbers in the chart with a positive sign. And if it's two-tailed, you have to use two tails with a negative and one with a positive. So you're going to have two critical values. Now the two tails are a little tricky because if you notice in our diagram here, we have that our critical values are located at 1/2 of our level of significance. So you're not going to use, so let's say the level of significance is 0.1. You're not going to go to 0.1 in your chart. You're going to go to 0.5 or 0.05 because that's half of that, okay? All right, so let's start with our first example. We have finding a critical value for a left-tailed test. Find the critical value T0 for a left-tailed test with a level of significance of 0.05 and a sample size of 21. So first we specify our level of significance. Our level of significance is 0.05. The degrees of freedom is going to be our n value minus 1. So 21 minus 1 is 20. And now we're going to use our chart. Our row is going to be 20 and our column is going to be 0.05. So let me just pull that chart up here. Okay. So we've got 0.05 for one tail and 20 for the other one. So our value is 1.725. Okay, so we have that our t value equals 1.725. However, this is a left-tailed test. So since it's a left-tailed test, our value for t sub 0 is negative 1.725. Okay, because that's the rule. If we have a left-tailed test, it's a negative t value. All right, let's look at the next example. So same thing, finding a critical value for another left-tailed test. This time we have a level of significance of 0.01 and a sample size of 14. So first we find the degrees of freedom by doing the sample size minus 1. Okay, and we are going to use left-tailed test, and we're going to use our level of significance of 0.01. So let me bring that chart back up. All right, so we have level of significance of 0.01 in one tail. Degrees of freedom are 13. So our value is 2.650. So our t value is 2.650. But again, this is a left-tailed test. So our t sub 0 is negative 2.650. Okay? All right, now we're going to try a right-tailed test. So find the critical value for a right-tailed test with a level of significance of 0.01 and a sample size of 17. So we have degrees of freedom. 17 minus 1 gives me 16. And then our t value, let's see what that would be. So we've got level of significance 0.01. Degrees of freedom are 16. So we have degrees of freedom 16, level of significance 0.01. That puts me at 2.583. Okay, and then since this is a right-tailed test, we just keep it as a positive. Okay? Okay, next example, we've got a critical value for a right-tailed test again. We have a level of significance of 0.10, and we've got a right-tailed test and a sample size of 9. So first we find degrees of freedom. 9 minus 1 gives me 8. Next, we're going to use our chart. So we have degrees of freedom would be 8. One tail of 0.10 right here. That puts us at 1.397. So we've got t equals 1.397. But again, since it's a right-tailed test, we would just use the positive, which is the same thing. Okay? All right, next one is the two-tailed test, and that's where you have to be a little bit careful because you're not actually using that 0.10 level of significance in your chart. So we actually have to do first the degrees of freedom, which would be 26 minus 1, giving me 25. But then we have to do half of our level of significance because it's being split up into two tails, the tails on the left and the tails on the right. So half of 0.10 gives me 0.05. So when you look on your chart, you're actually looking at degrees of freedom 25 and level of significance one tail 0.05. So we have degrees of freedom 25 and then one tail 0.05. And we go down and it's 1.708. But remember, we have two tails. Okay, so we have negative T0 and positive T0. So we have positive 1.708 and negative 1.708 because you have two tails that you're looking for. And the critical values are going to be that 1.708, but the one on the left is negative, the one on the right is positive. All right, last example. Two-tailed test again. And this time we have a 0.05 level of significance. So first, degrees of freedom. 16 minus 1 gives me 15. And then we're going to do half of that level of significance, split it up. Half of 0.05 gives me 0.025. So now when we look on our chart, we have degrees of freedom, 15, and 0.025 in one tail. We go down 2.131. And again, I have two tails. Positive 2.131 and negative 2.131. Okay? All right, so like I said, just very basic stuff today. Just finding those critical values. Your assignment is to do these problems down here, and you're going to turn all 6 of them in. The instructions say to find rejection regions. We didn't cover that yet. So you're just finding the critical values for all of these problems, okay? If you guys have any questions, let me know.